first thing we have to recognize about the demand for factors in general, and for labor in particular, is that such demand is a derived demand. What I mean in this key definition is that factor resources usually do not directly satisfy consumer wants, but do so indirectly by producing goods and services. For example, no one wants to consume an acre of land, a John Deere tractor, or the labor services of a farmer. But households do want to consume the food and fiber products these resources help produce. Similarly, the demand for automobiles generates a demand for automobile workers, just as the demands for such services as income tax preparation, haircuts, and child care create derived demands for accountants, barbers, and child care workers. Now here's our first important insight. The derived nature of resource demand implies that the strength of the demand for a factor such as labor will depend on two things. One, the productivity of the factor helping to create the product, and two, the market price of the product that the factor is helping to produce. Take a look at this figure and see if you can fill in the question marks with an up or down arrow as we pause the presentation. Did you get it right? If the productivity of a factor increases, so too will its derived demand. But if the market price of the product the factor is helping to produce rises, consumers will buy less of the product, so the derived demand will fall. That should be pretty intuitive, but let's flesh this out now with the following table. Here, for simplicity, we assume that a firm adds one variable resource, labor, to its fixed plan. Note that as the units of labor increase, the total product increases, but the marginal product of labor decreases. What law of economics do you think is responsible for this? That's right, the law of diminishing returns. And in the table, for simplicity, we are assuming that diminishing marginal productivity sets in with the very first worker hired, as seen by the drop in the marginal product from 7 to 6 in the third column. Note, however, that the derived demand for the resource also depends on the price of the commodity it produces. Column 4 adds this price information. Here we see that product price is constant, in this case $2. This is because we are assuming a competitive product market. Recall from Lesson 5 that in such a case, the firm is a price taker in the product market, meaning that it can sell as few or as many units of output as it wants to at this price. Now, multiplying column 2 by column 4, we get the total revenue data of column 5. From these total revenue data, we can then compute a very important sixth column, the marginal revenue product, or MRP. In this key definition, the marginal revenue product is the increase in total revenue resulting from the use of each additional variable input, in this case, labor. This marginal revenue product is indicated in column 6. Try and fill in the blank boxes now as we pause the presentation. Did you get it right? Here's what the table should look like. Now here's a very important point. The MRP schedule in columns 1 and 6 provides us with the firm's demand schedule for labor. To explain why, let me introduce two very key concepts: the marginal productivity theory of resource demand and the profit maximizing rule. Here's the way to think about the profit maximizing rule and how firms maximize profits when it comes to deploying factor inputs like labor. To maximize profits, the firm should hire additional units of labor so long as each successive unit adds more to the firm's total revenues than it does to total costs. Intuitively, what we're saying is that when a firm decides to hire, say, an additional worker, it must evaluate how much that worker will increase the firm's profits. It will do so by comparing the extra revenue generated by the extra output produced by the additional worker to the cost of employing that worker. Now, we already know what the firm's addition to total revenues is. What term do we use to describe it? Let's pause here as you think about that for a minute. That's right, the firm's addition to total revenues by hiring an additional worker is simply the marginal revenue product. Now, what about the addition to cost? Here, we can define the marginal resource cost simply as the amount that each additional unit of a factor resource adds to the firm's total resource costs. Given this key definition, we can restate the profit maximizing rule. It will be profitable for a firm to hire additional units of a factor resource, such as labor, up to the point at which that resource's marginal revenue product, MRP, is equal to its marginal resource cost, MRC. Think about it this way. If the number of workers currently employed by the firm is such that the marginal resource cost of the last worker is less than the marginal revenue product, the firm can clearly profit by hiring more workers. However, if the number of workers already hired is such that the MRC of the last worker exceeds the MRP, the firm is employing workers who are not paying their way, and it can thereby increase its profits by laying off some workers. Now here's a tough question. Under the assumption that the labor market is perfectly competitive, what do you think that the MRC will be equal to? Let's pause now as you write down your answer. Well, the answer is simply this. In a perfectly competitive labor market, the marginal resource cost equals the wage rate. Let me repeat this key rule. In a perfectly competitive labor market, the marginal resource cost equals the wage rate. And given this key rule, how might we now restate the complete rule for profit maximization under perfect competition as it pertains to the labor market? Let's pause now as you jot the answer down. Well, the complete rule for profit maximization in a competitive labor market is simply this. The marginal revenue product, MRP, will equal the marginal resource cost, MRC, will equal the wage rate, W. To illustrate this MRP equals MRC equals W rule, let's return to our previous table. Suppose now that the wage rate in this market is $13.95. How many workers will the firm hire? That's right, the firm will only hire one worker. This is because the first worker adds $14 to total revenue and slightly less, $13.95, to total cost. In other words, the MRP exceeds the MRC for the first worker, so it is profitable to hire that worker. Now, what about if the wage rate is $9.95? How many workers will the firm hire? That's right, the firm will hire 3 workers. And it should be evident from this example that the MRP schedule does indeed constitute the firm's demand for labor. This is because each point on the schedule or curve indicates the number of workers that the firm would hire for each possible wage rate that might exist. So from this table, why don't you try now graphing the demand curve for labor as we pause the presentation. Does your graph look like this? Note that the location of the curve depends on the marginal productivity of the resource and the price of the product. Under pure competition, product price is constant. Therefore, diminishing marginal productivity is the only reason why the resource demand curve is downward sloping. Okay, that was some pretty heavy lifting. When you are ready, let's move on to the next module and try to solve the mystery as to why companies decide to raise people's wages at times.